So good morning to all. Today we are going to see the topic types of DC generator from Unit 2. The subject is basic electrical and electronics engineering. So generator is nothing but it converts the mechanical energy into electrical energy. So what are they means? So majorly DC generators are classified into separately excited and self-excited. Self-excited GD generators are uh, classified into series generator, shunt generator, compound generator. Compound generators are further classified into long shunt, short shunt, compound generators. So here we can see that classifications of DC generators: self-excited, and separately excited. Separate self-excited generators are further classified into series generators, shunt generator, compound generator. So let me see one by one. Separately excited DC generators is nothing but the field coils are excited from the external DC source, which is shown in that this is a field coil. It is excited from the external DC source. So this diagram shows the how the DC generator separately excited generators are connected. The voltage is developed across the output side. The output voltage depends upon the two things: the speed of the rotating armature and field current. The output voltage depends upon the two parameters and speed of the armature and also the field current of the field winding. So this is the equation from DC separately excited generator. So from the diagram we are inferring that this is the generated EMF. Here the current is leaving from this armature is IA. It is directly connected to load side. So your IA will be equal to IL. That is what we are written here. Your armature current will be equal to load current because your armature is seriously connected to load. And what is the terminal voltage? Terminal voltage is nothing but voltage at the load side. It will be denoted as V. So generated EMF will be EG. The voltage drop across the armatures we are written as IA RA. So if we apply the KVL to this loop, we will get this equation. V is equal to Eg minus Ia Ra. So what is the electrical power developed means? The generated EMF into Ia. That is power is nothing but V into I. So here the EMF generated is Eg. The current flowing through armature is Ia. That's why we are writing Eg into Ia. So what is the power we are delivering to load side means? That is the generated EMF minus the losses in the input side. So the generated EMF will be Eg into Ia. The losses in the armature will be we are written as minus I square Ra. We are taking Ia is a common. It will be written as Ia into Eg minus Ia Ra. So it will be equal to V. So that's why we are writing V into Ia. So what are the things are IA is the armature current, IL is a load current, V is a terminal voltage, EG is a generated EMF, RA is a armature resistance. So next one is a self-excited DC motor. A self-excited DC motor is a device in which the field windings are supplied by the generator itself. So if we in the separately excited DC motor, the field windings are excited separately, where in field windings are excited by generator itself. So here we can connect the field coils in parallel to the armature, or we connected in partially series or partially parallel with the armatures. So based on that we can classify it as a self excited motor as series wound generator, shunt wound generator, compound wound generator. So now first we see the series wound generators. So this is a diagram of the series wound generator. Here your field winding will be seriously connected to the armature. So that's why we are calling this is the series wound generator. So from the figure, since field winding is connected seriously, so that resistance we are written as RSE, that is series coil resistance. The current flow through this field winding will be ISE, current flowing through series winding. Then we can write that here armature winding and field winding and loads are connected seriously. So we can write all this current will be equal and commonly we denote it as I. So here we apply the KVL to this loop. The voltage across a load will be identified. Here we are considering the voltage drop will be there in the brush side also. So it will be written as Eg minus I into Ra plus RSE minus brush voltage drop. So here also power delivered by this generator is Eg into I, and power delivered to load will be equal to V into I. Next one is a shunt wound generator. Here your field winding will be connected parallel to the your armature winding. So what is it we infer that this resistance will be called it R shunt. And if you see the current flow, this field winding will be I shunt. So this I shunt current will be, we can write V divided by R SH. How we are writing means here load and armature and field windings are all connected in parallel. As we all know that in parallel connected circuit, so the voltages are equal. Here the terminal voltage will be V. The current flows through field winding will be ISH. So according to the Ohm's law, V is equal to I into R. So I is equal to V divided by R. So we are writing IHS is equal to V divided by RHS. Here in this node we apply the KCL. Here all the IL current, IHS currents are leaving, IA currents are entering this node. So we can write IA equal to IHS plus IL. The voltage drop across load will be applied by applying KVL in this loop. We will get V is equal to Eg minus IA RA. The power delivered, so we can write the current will be IA. So generated EMF will be Eg. So we can write Eg into IA. The power delivered to load will be PL equal to V into IL. So this is the compound generator. Here we have two configurations, short shunt and long shunt. So in short shunt, we can see that our field winding will be connected, partially connected series, and one field winding will be connected parallel to that. In long shunt, your armature winding is connected seriously. Your field winding coils are connected seriously, and one more field circuit will be connected parallel to this one. So that equation for short shunt is here the current will be equal to the series field winding equal to load current. So the field current will be written like this. The armature current will be by applying KCL to that node, we will get this. By applying KVL in the armature closed loop circuit, we will get the terminal voltage. And power developed in the armature and power delivered to load will be right like this. Long shunt also we are applying the same procedure, so you will get the following equations. So thank you to all.